That's
That's
right.
right. Yeah, I just want to say welcome everyone to Software Craftsmanship. This is our first virtual meetup, and thank you for joining us. Wow, I'm hearing myself way after I say the things. So just wanted to say thanks, Ed, for joining us, and look forward to the talk. Thanks.
Sorry, I cut the wrong microphone. I was trying to get it isolated to just me, and I ended up cutting me too. Thanks for the heads up there, chat room. So we've got some additional folks coming in from outside of the Cincinnati area because we're live on Twitch, but mainly we're broadcasting to the Cincinnati folks for the Cincinnati Software Craftsmanship Meetup. I was just saying, this is a talk that I developed in started doing at various conferences. One of the conferences I did this at was the Star Trek conference up in Columbus, Ohio, which is why you might notice that some of the visuals are very cartoon, comic book like, because that conference is really cool. It's a fun conference to go to. Unfortunately, it got canceled like many other things this year, and it normally it coincides with a big movie for the year. So this was created for the movie last year, the Avengers movie, but it's kind of got a nice Spider-Man Into the Spider-Verse theme, so you might recognize a little bit of that in there. So it's a lot of fun. We're gonna talk about WebAssembly and a couple different ways that WebAssembly is used today. We'll talk quite a bit about Blazor, so it's a web framework that Microsoft is deploying to WebAssembly. We'll talk a bit about that as well. So hopefully you enjoy it. My name's Ed Charbonneau. I'm a developer advocate for Progress Software. So we make the Telerik UI brand of tools and lots of other cool stuff like Kendo UI. We're going to start with a little history about the internet. So let's take a step back to 1995 when we had something called Netscape Navigator. This is what the web looked like back in the day. Netscape folks chose JavaScript. There was actually some competing technologies. Java was one of them, but they chose JavaScript to be their primary scripting language for Netscape because it was simple, dynamic, and it appealed to non-developers, right? So this is 1995. You can picture, kind of what the web looked like back then. Web pages weren't very complex, mostly text and not a whole lot of interaction. Fast forward many years, 2009 timeframe, jQuery is like the big deal, right? Everybody's doing some jQuery, and Chris DeMars, Salt and Burnham in the chat room. Chris says, back when I started. So if you folks at the Cincinnati group don't know Chris, he's in chat with us today. He did a podcast with me. We were talking about this before the show started. Good accessibility guy. So Chris says he started back in 2009 when jQuery was the hotness, and jQuery was simple, so it kind of fits that bill. But today things are kind of beyond simple, right? Things have gotten a lot more dynamic, and with that, I think the appeal to non-developers is not part of this argument anymore. So simple, we went from simple and appealing to non-developers to this whole thing. So we've got this giant JavaScript ecosystem that's cropped up, and oh, sorry, not in 2000, or sorry, not in 2009, but in 96. Gotcha, man. It's very much the same for me. So we've come from this Netscape generation all the way through to these modern applications that have so much more interaction, and we have maps like this example all over the US. You can just like pan, and we have rich dashboard applications, line of business applications, all these things coming through the web. So now our focus is shifted to speed, portability, flexibility. These are the things we want from the web, not the simplicity and non-developer friendly stuff. So this is where our WebAssembly comes in. So WebAssembly is a new web standard. So this is a web standard. This is part of all of the normal evergreen browsers. So Chrome, Firefox, and even Safari, and the latest and greatest versions of IE and Edge even have WebAssembly. So this is a web standard technology that uses an assembly-like format. It's an assembly-like format that executes code inside of the web browser. So why WebAssembly? Again, let's talk about speed. That was one of the things I outlined earlier. So we have, first of all, smaller files, potentially using WebAssembly. So this means that we can download those files faster. WebAssembly is, it's already parsed and compiled, so we have to decode and execute WebAssembly files, and this process is faster than downloading a JavaScript file and compiling that inside the browser and building an abstract syntax tree and all of the things it has to do to make that JavaScript runnable. We have the ability to do compile time optimization outside of the browser. Now, the browser does do some compile time optimization on JavaScript, and it's gotten pretty good at it over the years, especially with the modern day JavaScript frameworks that have come around. The major browser manufacturers are they're doing a lot of optimizations for us, but with WebAssembly, we're able to do these compile time optimizations outside of the browser. And it's near native speed. And when I mean near native speed, if I have an assembly that was built for CPU, on the web, it's going to run in WebAssembly 20% slower than it does on CPU. That may sound like a performance hit, but it's actually, you can actually get pretty great performance out of WebAssembly. If you're doing a lot of heavy lifting, doing a lot of calculations and things like that inside of JavaScript, you may actually be able to write that in WebAssembly, compile it externally, and run that faster at near native CPU speed. Portability is another big deal. We can use existing code bases and port those things over to the web, and I've got some good examples of that. I'll show you a fun one here in just a few minutes. We can run without plugins. Again, this is a native web technology, so we can run these things in the browser without plugins like Silverlight and Flash and all of those things that came before it. We don't need those requirements up front. We don't have to have our users downloading some plugin to make WebAssembly work. It just comes out of the box. Flexibility. This one comes from the fact that we can use other frameworks, other languages and other frameworks from outside the JavaScript ecosystem. And this brings in other ecosystems to the web. So we not only have the JavaScript ecosystem, but we have other ones too. And none of these things are mutually exclusive, so we can mix and match things. And I'll talk a bit about that in a little bit. Right, so if we talk about what is happening in the browser right now with a typical web application, we have HTML and JavaScript. Sometimes that's even inline JavaScript. We load those things into the browser, and those go through a parser. The parser builds the JavaScript into an abstract syntax tree and compiles that into bytecode, and then it runs through a just-in-time interpreter, and then we can call web APIs and do native things inside of the browser, like file storage, interact with the DOM, stuff like that. WebAssembly, the way I like to think about it is it's kind of an interface. So we're opening up this new interface in the browser, and we've got another way of injecting our code into the browser through this new interface. And it bypasses the need for a parser and compile, and it's just bytecode the browser already understands. So what's nice about this approach is we can bring in other technologies from that are not just strictly JavaScript. So we could have C and C++ and Rust and Go and all of these other languages and compile those into WebAssembly code and use those natively in the browser. So this opens us up to a lot of new ideas. Let's talk a little bit about what WebAssembly code looks like. Typically, you're not going to write WebAssembly directly. So you're going to use something else, another language like C or C++, and you're going to compile that into WebAssembly code using some tooling. And we got a good question from chat here that Aaron Stanley King is asking, does it work in IE? And I believe IE 11 has WebAssembly compatibility. Might need to fact check me on that. I know Edge for sure, and all of the other major browsers, Firefox, Chrome, and Safari all have compatibility. Now, earlier versions of IE is definitely a no-go. You're not going to have it there. I think the latest and greatest does, though. So we've got our C code. We can compile that into bytecode. And then we also have this format called WAT, which is like a WebAssembly text format, which you could technically write WebAssembly code in, but you can see how it looks. It's not going to be very user-friendly. Somebody popped a link in chat. Thank you very much. And it looks like even IE 11 doesn't support WebAssembly. So it is just all the modern evergreen browsers. Edge definitely does, though. So, if you're looking at kind of a closed work scenario where you have machines that are running older versions of Windows and IE, it may not be a choice that you can have. But thanks for the help there from the chat room. Accidental developer with the can I use link there. So with this new technology, what happens to JavaScript, right? We've got this new thing we can use, all different types of coding technologies and languages. Does that mean that all of this JavaScript is obsolete? Is it like Thanos, where we're going to snap our fingers with WebAssembly and like half of our beloved JavaScript frameworks are just going to disappear? I'll leave that question up to all of you, but I think as I go through these examples, you'll see that JavaScript is still very much part of the picture. So we've got three technologies that I'm going to talk about today. One of them is using C and C++ with the Emscripten toolset. Rust also uses this, and they have some interesting packages or crates that revolve around WebAssembly as well. And then there's the .NET side of things with Blazor and C#. So we're going to talk about each one of those individually, and we'll see how each of these different ecosystems and languages tackle the problem. First of all, let's talk about Emscripten. and what exactly that is. So this is a tool chain for compiling WebAssembly. It uses the LLVM pipeline, and it runs C, or you can compile C and C++ and get near native speeds through WebAssembly without plugins. So it's a pretty powerful tool chain, and it's able to convert some C# code, or compile some C# code, or I keep saying C# code, into WebAssembly. So got a little example here of what that would look like. So I've got a very simple C file here. And in this very simple C file, we just have a main function with a return value. And we're going to see exactly what we could do with that. First of all, again, I put up that slide about what happens to JavaScript with the WebAssembly scenario. Sorry about that. We have the need for JavaScript here because we have to load the WebAssembly file into the browser, and we need to do that using JavaScript. So as much as people want to pretend like WebAssembly is going to make JavaScript obsolete, we actually are required to have JavaScript around to get WebAssembly loaded into the browser. So the first thing we're going to do here is we're going to fetch this file main.wasm. That's what's going to get compiled out of this C file. And we're going to push those bits into an array buffer, and then we're going to execute that main function eventually. And we'll do that through this final instance.exports.main, and we'll actually execute that function. We'll dump the results into an element. We're going to say document.getElementById, and we're going to target the container of it. So if we look, lost my cursor here, there we go. So if we have an HTML page, we're going to locate that ID tag, that span that says ID equals container, and then we'll be using getElementById, and then we'll post the results of that into that element. So we'll actually be able to write the number 140,605,000. If you are an Avengers fan, that might actually mean something to you. Let's talk about Doom for a minute. So we can use this Inscriptin tool chain not only to kind of write just some basic numbers to the browser, but we can actually take very complex code and compile it. So existing applications that we might already have that are fully written in something like C, we can compile into WebAssembly. And that's what some people did with the Doom 3 game and the Doom engine. So this is actually a real thing. I'm going to try to pop out of my browser here for a minute. And I actually have this running in another tab over here. And you can see it's a little difficult to mouse through, so I'll try my best here. But I can actually look around this 3D world here. This is actually the Doom 3 game that somebody's compiled into WebAssembly. And any of this kind of craziness where I can't look around very well is just the mouse mechanics here aren't very great inside the browser, trying to target the window with the game in it. But if you put this full screen and run around in it, it actually does run pretty well. You can see in the upper right hand corner, I'm actually getting like 30 frames per second, even though the mouse is making this completely unplayable at the moment. But you kind of get the point. We can get pretty creative with WebAssembly. We can pull in some existing C and C++ code and do some pretty crazy stuff with it. I mean, I'm playing Doom 3D Doom 3 in the browser right there. So pretty cool stuff. So you can port existing applications with the Inscriptin pipeline and C and C++. That's very useful for folks that are used to doing C development. If you're not a C developer or you're a Rust developer that's interested in WebAssembly, Rust is an interesting take on all of this. So Rust is a C-like language. It has some of the similar strengths to C++ in that its language is similar. It's fast. The files that it produces are really small. It has some pretty well-structured tooling around WebAssembly. And then one of its strengths is that it has this garbage collection hinting during compilation. So it helps developers understand when resources should be cleaned up and things like that, whereas C and C++ kind of leave you up to disposing of those things on your own. This has a garbage collection compiler feature that's pretty interesting. You should read about that if you're interested in Rust. And Rust comes with this idea of crates. In other languages, we call these packages, whether they're NuGet packages with .NET or NPM packages in JavaScript. Crates are kind of the same thing in the Rust world. And there's a lot of WebAssembly crates like WASM bindgen and some other things that help us build WebAssembly apps with Rust. So WASM bindgen is pretty cool because it has this thing that helps us do interoperability with JavaScript. So this gives us the ability to make calls from JavaScript to Rust and from Rust to JavaScript. This is super helpful if you have existing JavaScript libraries that you want to use in your Rust application, or if maybe you need to make calls from your Rust app to native DOM APIs to do things like update the DOM or maybe call out geolocation or some of the other browser behaviors that may not be accessible through the Rust language. So these things all help. There's also a web-sys package that does some built-in DOM manipulation features, WebGL, web audio, and those type of things. So let's look at an example of the Rust scenario. So you'll see a lot of directive attributes around the code here, and this is helping the bindgen tools understand how to interact with the code and compile it to WebAssembly. So in this example, we're going to post an alert. So like around line 7 here, you'll see a function alert, and we're going to pass in a string to that alert. And we're going to use this WASM bindgen to actually call a native API on the browser and pass some data to it. So I'll have this alert function, and the alert function is actually the function in the browser that pops up the native alert dialog. So if we look at our JavaScript file for this, it's a lot more simple than the C# or the C++ example. That's because we have these WASM bindgen tools that kind of step in and help us with the bootstrapping of this WebAssembly application. So in here, we can call in WASM bindgen directly into JavaScript, and that's going to give us some helper libraries to get us started. So we'll say WASM bindgen, load the WASM file. It's going to be main_bg.wasm. That's going to pull in our WebAssembly bits, and then we're going to call the run app function, which is going to call the greet method from our WebAssembly code via Rust. And then we can actually pass in the text of world and pop up a native browser dialog that says hello world. So on our HTML side, we'll have a couple of scripts that we load in, and then we get this native hello world message inside of the browser. Now, it may seem like a very simple demo, and I just want to say there's a lot of complex things actually happening to make these things so simple. So you only see I want to call it maybe 5 lines of code here on the left-hand side in main.js. And then we saw earlier the WebAssembly, or sorry, the Rust code that gets compiled into WebAssembly is only 13 lines long. However, something really interesting about WebAssembly is, first of all, WebAssembly doesn't have access to native DOM APIs. So we're going to need JavaScript to call into those. And that's where WASM bindgen comes in really handy, is because somebody's already put together tools that can make those calls and do interop for us. The other thing that's really interesting is WebAssembly only has 4 types. All 4 types are numeric types. So in this example, we're passing a string, hello world. We're passing a parameter into the application, consuming it, and passing out the string hello world, and alerting that string to a native web dialog box. So in order to get that string through WebAssembly as a parameter input and output, we have to encode and decode our string into those numeric types that exist in WebAssembly. Now, the crates, the bindgen crates that we have here are doing that work for us behind the scenes, so we don't have to deal with that. So we have to know a lot less to do a lot more, and I think that is a pretty cool aspect of WebAssembly. Before I get started on Blazor, Blazor is going to be a big part of the rest of the talk here. I want to show a place where you can go play around with WebAssembly. So this is going to be called WebAssembly.studio. And